Okay, we are going to be going through section 2.2 today. And when we look at section 2.2, we're going to be looking at the period of the sine and cosine functions and talk about that, just kind of review that before we get into some of the main graphs. So basically, we have talked about the period being the width of the graphical shape that repeats itself. It's supposed to say repeats. Okay, so one of the things we learned about a basic sine wave is we learned that we have these 5 critical or key points going like this on a basic sine wave from 0 to 2 pi. What we have is 5 key points like this. So the sine wave went through the beginning, the maximum, the midpoint, the minimum, and the end point like that. So those are 5 key points, and we said that the width of that shape was 2 pi units. Okay, but we have a general formula that's now going to say 2 pi over the absolute value of b, where b is a number that's the coefficient of the x. Okay, so it works for either the sine or the cosine. I think I meant for that to be the cosine. Okay, the amplitude is 1/2 the distance between the crests of the waves. So in general, we talked about an amplitude being 1/2 the distance from the max to the min. So that distance from the max to the min is 2. The distance from -1 to 1 is 2. So we said the amplitude's 1. But in general, in talking about this equation, the amplitude is defined to be the absolute value of a. So that value of a multiplies the y values by a. So it stretches the graph vertically. So we multiply all y values by a, and then that gives you the amplitude. Okay, the phase shift is going to turn out to be this number c. So it works out like this. Okay, amplitude, if you have x minus c, that's going to be a phase shift. And that's going to be to the right, c units. Okay, if it's x plus c, I think I meant on this for this to say x plus c, then that's going to be a phase shift to the left, c units. Okay, then if you look at the value d, that's going to be a vertical translation up d units. And then if it's a minus, that's going to be down d units like this. So what we're ultimately wanting to try to get a handle of is if you have a general sine or cosine, the sine and cosine work the same way, and you have this in a factored form, that b is factored out of an expression like this, then there's a couple of things that can happen on this. You've got a is the amplitude. That's a stretch shrink vertically. The period is defined to be 2 pi over absolute value of b. Amplitude's absolute value of a. If you're in a factored form, if that b is factored out of that, then you're going to have a phase shift of c, either left or right, and then you're going to have a vertical translation of up or possibly down d units. Okay, so that's what we're trying to get at, first of all, is being able to identify those before we get into the graphing. Okay. Well, I thought I'd add this on here. So many young people are into tattoos these days. I'll challenge any of my students to get a graph of the sine wave. That would be very intimidating to any bad boys on the street. So if you come around with a sine, cosine, tangent wave, you'll scare them off. Okay, so go get you a sine wave like this guy did. Alrighty. Okay, so let's go through and let's look at on the next page. We'll begin now to put things together. So first of all, we have to put this in a factored form. This is not in a factored form. So you have to write this as y equals -3 times the cosine. I'm going to use a bracket. I'm going to factor that 3 out like this. So I'm going to have an x there plus. Now I basically just do this. I just take the pi over 3 and I divide it by the 3 that I'm taking out as a factor. You always take the coefficient of x out as a common factor. So that's really pi over 3 times the reciprocal of 3. so that's going to be pi over 9. Okay, so the factored form would be this. Okay, and it's always a good idea to check yourself and make sure you're right. See, that's 3 times x is 3x. Then if you take 3 times pi over 9, what do you get? You get 3 pi over 9, which of course reduces to pi over 3. All right, so what we're going to do is identify all the parts of this then. Okay, so first of all, the amplitude is going to be found by using that number. So the amplitude is going to be absolute value of A, which is that negative 3. So the amplitude is going to be 3. That's going to tell you that the waves stretch up and down by a factor of 3. Okay, the period basically comes from this number. Okay, it all is defined by that coefficient of x. We call that the number b. So what we would have on this then is for the period, we use the formula 2 pi over absolute value of b. So this is going to be 2 pi over 3 would be the period. Okay, the phase shift is not pi over 3. A lot of times students think that. The phase shift is this. Okay, the phase shift, remember, you need to have that in a factored form. And if it's in a factored form, then your phase shift is going to be that value like this. So we'd say we have a phase shift of pi over 9. Since there's a plus sign in there, that plus sign tells you that you're going to the left. Okay. All right, and another thing is, if you're going to the left, usually we write the phase shift as a negative. Vertical translation, there is no vertical translation because you would be looking for like a number added to that like that. So there's no vertical translation. Okay, next problem. Again, we don't put this in the factored form, so we're going to say y equals 2 sine, draw a bracket, and then factor the 3 out of that. So you're going to have x plus something. Again, you just take pi over 2, divide it by 3. So that's really pi over 2 multiplied by a third. So that will be plus pi over 6, like that. Right? So here's where everything falls from. Okay, the amplitude goes there. So the amplitude is 2. The phase shift, or the period, comes from here. The formula is 2 pi over b, so that's going to be 2 pi over 3. Okay, phase shift is this number, so that's going to be a phase shift of pi over 6. And again, this is going to be the left. Since it's a left phase shift, generally we do that. And then this problem does not have a vertical translation. Okay, so you're just trying to identify all the parts. Okay, next problem. Let's see, factored form. This is not in a factored form, so you must put it in a factored form. So this is y equals, now I'm going to put this minus 5 at the end just to emphasize something. You don't have to, though. I'm going to go ahead and factor a 6 out of this, like I've been doing. And then I'm going to take that negative 5 and put it to the end. That way you might see the vertical translation a little better. Okay, so we're just taking pi over 2. When we factor, pi over 2 needs to be divided by 6. Whoops. Pi over 2. Divide by 6 really just means pi over 2 times 1/6. So that's going to be pi over 12. Okay, check it too. Look at this. 6 times x is 6x. And then that's 6 pi over 12. 6 pi over 12 reduced to pi over 2. You factor something, you should check it. Okay, the amplitude comes from the absolute value of that number. So that's 2. The period comes from the formula 2 pi over b. So that's 2 pi over 6. That fraction would reduce to pi over 3. The phase shift would now be that number, and that's pi over 12. Since there's a plus sign, that's going to the left again, so use a negative. And then finally we have a vertical translation of down 5, and that's because that is a negative number. You're subtracting from the y values like this. So technically what kind of happens on this, that's as we begin to learn our graphing, I think that what's kind of important on this is you make a connection between maybe what you learned in a college algebra class. So like if you had a function f of x equals negative 2, and let's just say that you had something like 6 times x plus, well, instead of saying pi over 12, let's say 12 minus 5, and that was a squaring function. Well, you know that's a parabola, so hopefully one of the things you learned is that this was a left transformation. this was a down transformation. Okay, that really, what it's doing on that is it's really doing making the waves come together, the parabola come together closer. So that would be what we call a horizontal shrink on that. And then you may have learned that this is a vertical stretch. And maybe you learned that that was a reflection over the x-axis. All functions work the same way. Okay, so what we have here, really we have a left transformation. We just happen to call that a phase shift. This is still down 5. Okay, this really is a horizontal shrink, but we just define it by the period. The period changes. So it's pi over 3. This is still the same thing, although that's an amplitude, but an amplitude vertically stretches things. So it's nice to make that connection then. Okay, so I'm going to move this up, and I'm going to pause, and then I'm going to have you work on just the next problem. And you can go ahead and pause if you would like, and resume as soon as you're... Okay, first thing is hopefully you put this in the factored form correctly. So I'm going to factor out that 3. That should be 3 times x minus pi over 3 is what you should have got. Okay, so the amplitude is the absolute value of that number, so you should have got 4. The period is 2 pi over b being 3, so you should have got 2 pi over 3. Phase shift is this number, which is pi over 3. And then now this one should go to the right because of the minus sign. And there is no vertical translation. So that's what you should have come up with. Okay, next page. All right, this is generally just kind of telling you some of the steps you can take in graphing these things. You can refer to this if you need to. Then I got my joke. I love this joke. This just cracks me up. Okay, I mean, and if you're a girl and some guy says this to you, you should just slap him in the face. So he says, hey girl, what's your sign? It must be pi over 2 because you are the 1. Well, here's the joke. The sine of pi over 2, we've learned is 1. Okay, look at the expression on that girl's face. So I thought that was pretty funny. I don't know how people come up with these stupid math jokes, but that was a good one, I thought. All right, now if we go to the next page here, what we'll be looking at here is now we're going to begin to put together some graphs on this. So it's real important on these problems that you go through and identify everything. So we do have a period change on this one. So the first thing we're going to do is the formula for the period is 2 pi over the absolute value of b. So therefore, b is that value. So it's going to be 2 pi over 2. So that means that the period is going to be pi because the units cancel out. So that's very important. Now, this is a real important thing, and this is like, to me, one of the key things when you do this is you're going to figure out how to put these values on the transform graph. So you take that period, which is pi, and you divide it by 4. So that will give you the correct way to increment the x-axis when we go down and start doing our graph. Okay? So one of the things I'm going to do on this is we're going to go ahead and we're going to count this out now by pi over 4. Okay, we're going to do a graph of sine x, then we're going to do a graph of sine 2x and just kind of compare the differences between the two. So there's your sine x. We'll fill a table of values on that. Then we're going to fill a table of values out for y equals 2 sine x. So the first thing we want to go ahead and do is let's go ahead and let's just count this by pi over 4, the increment. So we'll start at 0, then we'll go 1 pi over 4, and we'll go 2 pi over 4, then 3 pi over 4, then 4 pi over 4. Okay, now you always want to be sure you reduce fractions, so of course that reduces to pi over 2, and this of course reduces to pi. So that would take you through one period. We're going to have 5 key points, and notice we're going from 0 to pi, so the period is changed. Okay, so what we're going to do is I'm going to go ahead and slide down to this graph for a minute, and let's go ahead and let's set this x-axis up. So we're going to go pi over 4, then we're going to go pi over 2, 3 pi over 4, and pi like that. And we're just going to make, we don't have an amplitude change, we have an amplitude of 1, so I'm just going to go to 1 and down to -1 on the y-axis, okay, like that. All right, so you always want to get that set up. Next thing you want to do is we're going to fill out a chart. Now we're going to go through and do the sine wave first of all. I'll just do this in like green or something like that. So again, if we go through and look at just the basic old sine wave, remember on a unit circle, we learned that the sine is just the y value. Okay, so we're going to go around and highlight these y values, and these are going to give us values for our table of values on our basic sine wave. Okay, so let's do that. Okay, so we know the sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is, whoa, what did I just do there? Pi, I think I'm getting ahead of myself. Yeah, that's 1. 3 pi over 2 is -1, sorry. And then 2 pi is 0 like that. Now what we're going to do is we're not going to graph that. What I'm saying is, if you do a period change, that's all that's happened on this graph is you've changed the period. So these y values are actually unaffected by that. So these things just come straight down. We're still going to be 0, 1, 0, -1, 0. So when we do our graph, it's the x values that change because all we had was a period change. Right, so now we're going to graph these. We'll just go down and graph these. So we have a point 0, 0. We have a point pi over 4, 1. We have pi over 2, 0. 3 pi over 4, -1. Like that. And then that would be our official graph when we go through and connect those dots like that. So that is the graph through one period of sine of 2x. Okay, now you can also check and verify your answer. So just pick like any point on here. Let's keep it simple. Let's use that. So if x is equal to pi over 2, I want you to notice if you plugged that in, you would have y equals sine of 2 times pi over 2. That'll cross out, and that leaves you the sine of pi. Well, if you look on the unit circle, the sine of pi is equal to 0. So that matches that y value, see. And you could do that over and over again on these points. You can check all the points. You just plug in each one of these x values, and they all should check. So that's how you do that graph. The idea is it's the x's that change, but not the y's when you have a period change. Okay, let's go to the next page then. And now we'll do one more that's got a period change. Now this one, again, what you have is the formula for the period is 2 pi over absolute value of b. Okay, now the b value in this one is 1/2. So we're going to do basically 2 pi divided by b. So I'm going to write it this way. Of course, that's really 2 pi times 2 over 1. So that's equal to 4 pi. So that new period is going to end up being 4 pi, like that. Okay. The amplitude is the number in front of the cosine. So that's your amplitude. So that's going to be 3. Okay, now we got to find the increments. The increment's a real big deal. So you want to take the period, which is 4, and you want to divide that by 4, so you get an increment of pi. So when we set up a table of values in a graph of the final product on this, that's what's going to change is the x values in that increment. Okay, so we have an increment of pi units. So what we're going to do when we do a graph of this, and we're just going to do a graph, not the amplitude, we're going to do this in 2 stages, we'll just count by that increment. If the increment is equal to pi, then just start at 0 and start counting by pi. So you just go 1 pi, 2 pi, 3 pi, 4 pi. And you've got 5 key points, see. And notice that 1, 2, 3, 4, 5 points get you to the end of the period. And that will always happen. That's the benefit of doing that increment, is if you count out by that increment, you should get to basically to wherever the period of the graph is. So see, these things right here should basically always match up when you count. That'd be your last key point. Okay, so here's basically what we're going to do on this. Now we're going to look at the cosine. We're going to look at the graph of the cosine of x. So that means we just need to go around the unit circle and look at the x values. We learned that the cosine is the x values on a unit circle. So we're just going to go ahead and fill in this chart now. All right, so what we have is the cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is negative 1, cosine of 3 pi over 2 is 0, cosine of 2 pi is back to 1. Okay, now here's what's going to happen. In the stage, when you do just the period change, the y values are not going to change. They come straight down. The period affects the x values, but it does not affect the y values. So they come straight down. Okay? So we're going to go ahead and we're going to graph that. I'm going to have you graph this basically in 2 stages. So let's go ahead on here and let's set up our graph, and let's increment our x-axis by pi. What in the world did I do? So always some surprise on this thing. Okay, let me say I must have hit something and screwed up on something there. I have no idea what I just did. Always a surprise on this thing. Always. I have no idea what I did. Okay, well anyway, for some reason that's not showing up. I have no idea what's going on with this funky thing. Okay, let me fix this. Let me pause and fix this. Okay, so I think I figured it out. So what I'm going to do is let's go ahead and increment this out. So that's pi. This is 2 pi. This is 3 pi. And this is 4 pi. And we're going to scale this because of this amplitude of 3. We're going to take the y values up to 3. And we're going to take that down to 3 like that. So we're going to do this. And then we're going to go ahead and sketch this graph in. So what we're doing on this is this piece right here. I think I kind of got this off track here a little bit. And I think that's what happened. So let me back this up. I think I just hit the wrong thing. Okay, I don't know. I don't know. Computers, you know how they do. They don't do what you want them to do half the time. All right, let me pause it one more time. All right, I figured out what's wrong. So I'm going to go ahead and just use this graph here. Just kind of extend that out a little bit. That's what I wanted to do. Okay, so let's do, get the increment put together now. So this is going to be pi, 2 pi, 3 pi, 4 pi. Like this, then we're going to go up 3. 1, 2, 3, and then we're going to go down 3 because of the amplitude. All right. Now, we're going to sketch in a basic cosine wave. Basic cosine wave starts high, then it goes there, then it goes low, and cycles through these 5 key points. And I'm going to do that in a dashed line. And we're going to label that y equals cosine of 1/2 x. Okay, because see, we handled the period change because we changed the increment. Now what we're going to do is we're going to work in the amplitude change next to get our final graph down. So all this is doing, this 3, what it's doing is it's multiplying the y values by 3. So it's just going 3 times 1 is 3. So this point right here stretches up to 3. Then this point, you take 3 times 0, it's still the same. So that x-intercept is not affected by a stretch. Then this point, we're going to do 3 times -1 gives -3. So that means this point stretches down to -3. And then by the same logic, this is 0, and then this goes to 3. So your graph is going to end up looking like this. So this would be your final graph would look like that. So that is y equals 3 cosine of 1/2 x. Okay? Now, let's do a check on this. I think you try to keep this simple. Just pick a point. I'm gonna pick 2 just because if I plug 2 pi in, it kind of works out nicely. So let's say y equals 3 cosine of 1/2 times 2 pi. Well, notice the 2's cross out, and you're left with y equals 3 cosine of pi. But the cosine of pi is, on a unit circle, is just the x value. So that's going to be 3 times -1, so that is -3. Okay, and if you look at that, well, that's what that point is. That has a y value of -3. So that checks and verifies our graph. It checks that one point's right. You can check all 5 points if you choose to, but generally if you check 1 or 2 and they're right, you're going to be pretty confident you have it right. Okay, so let's go to the next one here and get this one put together. Okay, so the first thing we have to do on a problem like this is we have to put this in a factored form so that we can figure out the phase shift. Okay, so this is going to be y equals 3 sine, and we're going to factor the 2 out. So we're going to get that worked out like that. So that is the factored form. Okay, factor that 2 out. Now let's identify everything. Okay, the amplitude is 3. The period comes from this number. And remember, the formula for the period is 2 pi over b. So 2 pi over 2 is going to be pi. There's your phase shift. So that's pi over 2 to the right. And then there is no vertical translation. Okay, so take the period and divide it by 4. And that will give you your critical points on the x-axis that you need to do. So it's pi over 4. Okay, so what we're going to do is we're going to take this information and then we're going to put this all together. So we are doing the graph of y equals 3 sine, let's do the factored form, 2x minus pi over 2. And we're going to do this in stages. Whenever you have a phase shift, the first thing that you always want to do is start at the phase shift. So we're going to really start this problem by graphing at the phase shift and do the amplitude last. Okay, so as we put this together, let's go ahead and let's get us a coordinate system put together here now. And we're going to go, let's just start kind of like this. Let me just put a general coordinate system on here like this that will encompass all the points we need. So I'm going to do something like that. All right, now what we want to do first of all is you want to put this increment in here. So let's go ahead and do that. We're going to count by pi over 4. So you just go pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. You can go as high as you want to. Okay, so let's just go like this. So let's write this as pi over 4, pi over 2, 3 pi over 4, pi, and then let's go all the way out to 5 pi over 4 like this. Okay, then swing to the left. And we can do that if we want to. Now I'm only going to do this graph probably over one cycle. Okay, so now this is what's real important, is that you follow a certain order on here. The thing that you always want to do is start really with the phase shift if you have a phase shift. Okay, it's just as easy to do this in a couple of steps as it is in multiple steps. So first of all, we're going to graph y equals sine of 2 x minus pi over 2. And what I'm going to do is very lightly sketch in the key points for y equals sine of 2x before there's a phase shift. All right, so what we need to do on this, we need to finish getting our axis kind of built together here. So we do have an amplitude of 3, so it makes a lot of sense to go up to 3 and then down to 3, -3 like this. Okay, now I'm going to do this this first thing, this graph of this sine of 2x very lightly in this blue color. So a sine starts at 0, 0. And I'm just going to lightly write little dots on this like this and just kind of cycle through a period of the sine wave like that, really lightly. Okay, and you can dash that in real lightly if you want to. Okay, and then what we're going to do is we're going to phase shift this. So step 2, I'm going to do this like in red, trying to color code this. I'm going to do this. So the phase shift is pi over 2 to the right, okay, in this problem. So that means this point right here moves to this point. Okay, that point right there moves pi over 2, so we don't worry about that point anymore. Okay, this point right here moves to this point. Again, we're going pi over 2, so that moves there. This point moves pi over 2 back to there, so we're done with that point. This point moves to here, and so forth. So I'm just going to kind of cycle through this now, and then we'll have one more stage to do. And see, now you can predict where the points are going to go. This point here is going to be there, and this point's going to be back there. So that gets you through several points, and we'll just keep going back with this. You know, just keep continuing through the pattern like this. Okay. So what we've done is we phase shifted the light blue graph that I tried to do there, pi over 2 to the right. And then the last phase, to get our final answer on this, what we're going to do, and I'll do this kind of in a dark blue, I guess, here, is we're going to graph, you know, the whole thing. Okay, so what we do is now all of these y values get multiplied by 3. So I'm going to start way over here. So I'm really doing 3 times 0. So that point still stays the same. On this point, I'm really doing 3 times 1. The y value is 1, so that becomes 3. So that point is stretching up to that point there. This point right here, you're doing 3 times 0, so it's not affected. Okay, so that point's going to go there. And see, once you get the pattern, you can tell this one's going to go to -3, that one's going to stay the same, that one's go up to 3, and you can just kind of draw the pattern. So once you get about 2 points, then you can predict where the rest of them go. So basically, we'll end up having that. And see, what I'm doing is I'm dealing with the red graph, so that point stretches down there. Then that would be the final product like there. Okay. Now, if you wanted to do a check, I would probably be tempted to use pi over 2 and plug that in because it's so easy. So I'm going to say, okay, y equals 3 sine of 2 times pi over 2 minus pi over 2. Let's see what y value we get, and let's see if this checks or not. So that's going to be y equals 3 sine of 2 times 0. So that's y equals 3 sine 0. So that's equal to 0. Okay, when you do that then. Okay, so that matches. Okay, sine of 0 is 0, so that matches up. So that would be a correct graph. Okay. Verify other points if you choose to. Okay, let's do this one. And you can do this in a different way. To me, I don't know if this is any easier or not, but you can start this at the phase shift. I'm going to just show you how you can do this problem in one step. So we can find the period. So again, the period is 2 pi over 2, so that's pi. The increment is the period divided by 4, and then the amplitude, of course, is 3. So what I'm going to do is I'm going to show you how I would do this just in one step. You know, just kind of keeping this simple. Okay, so when we do this, let's go ahead and let's set up the increment when we do this. Okay, so let's go through and just count by pi over 4s. I got pi over 4, pi over 2, 3 pi over 4, and pi. And then you can go up to 5 pi over 4 if you choose to. And we can go up to 6 pi over 4, which is 3 pi over 2. Okay, and it's just kind of up to you where you count to. Mainly, I like to have these things done over at least one period. So that's the setup for the problem. Now, this is what I do. We've got this thing in a factored form, so it's 3 sine of x minus pi over 2. So here's how you do this problem in one step. Okay, if you can follow this, man, then you got it made. All right, so what we know is we know a sine wave starts there. Okay, but however, what we're going to do is we're going to start with the phase shift. That's where you need to start. By changing the increment, we have dealt, and I think I'm missing a 2 on that, we have dealt with the period change. So what you do is move that point there. Now, just start cycling. You know that the next point on a sine hits the high point, but the high point's not going to be 1, it's going to be 3. Then it hits the midpoint. Then it hits its max, or the minimum is going to stretch down there like this. So you can go through and really do these problems in one step. If you start at the phase shift and then kind of reason out how the amplitude changes, then with practice you can do these in one step. And that's what I'd like to see you guys be able to do. Okay, let's see. Now that one, I think that's the same problem that we just did. So not going to do that again. I'm just going to bypass this. I don't know why I put this on here. This is kind of table of values way. Well, let's go through the table of values way because sometimes students do like doing it better that way. So when we start this off like this, let's just do a fill in the table of values. So we know the sine basically is all the y values on a unit circle. So we're going to do this. Fill out the chart real quick. The faster you get this memorized, the faster you can do your homework. So this is 0, 1, 0, -1, 0. So that gives those values like that then. Now what I'm going to do is I'm going to just kind of take a little picture of this, and then I'm going to send this to the next page then, and just so that we can kind of verify this as we do this. Okay, so let's go to the next page, and let me put this table of values in here. Let me paste it. There we go. Okay, so let me see if I can move this thing up here a little bit somehow. Come on, just behave and do what I'm telling you to do. Oh, come on, come on, come on, come on. What is this crazy thing doing? Computers. They only do what they're told to do. Okay, well anyway, let's do this. Okay, let me try one more time to move this stupid thing up here. Okay, so I think I got it figured out here. Okay, so what we're going to do now, if we're going to find the new 5 key points, okay, we're going to divide each x coordinate by b and adding c. Okay, so what we're graphing on this is, let me go back to the page and get what we're graphing on this. I think I've kind of, there we go, there we go. Okay, so let me write that down so I can show you this methodology. I never do it this way. The textbook does it this way, so it's kind of up to you. Sometimes students understand it better this way. So what we end up doing on this basically is this. Okay, so when we do the new chart, now let's see, we're graphing basically y equals 3 sine of 2x minus pi, like this. So what they're saying that we can do is divide each coordinate by b and adding c. So what the way they're doing on this is this is the value of b, and then you're adding c to that, which is the phase shift. So if you're in a factored form, you have y equals 3 sine of 2 times x minus pi over 2. So we're in a factored form. So they say just divide each x coordinate by b and add c. So like if you took this x coordinate right here of 0, and you divide it by b, which is 2, then you add c to it, which is this, pi over 2, then they're saying, well, you would get a new key point. Okay, so that would be pi over 2 like that. Okay, then you can continue to do this each time to get these x values in your chart then. Okay, let me erase that and move that over like that. So let's go now to pi over 2. So we got pi over 2. They're saying you can multiply by b, which is 2. Then you can add the phase shift like that. Okay, well that gives pi over 2. Or actually, let's just leave this as 2 pi over 2 plus pi over 2, which will give 3 pi over 2. Like this, okay? And we can continue on with the pi. Okay, again, take it, divide it by b. So take the pi, divide by b, which is 2 in this problem. Then add c, which is pi over 2. So that gives 2 pi over 2, which ends up giving you pi like that. Okay? I just realized I messed up on one of my points, so let me go through and correct that. I'm kind of getting in a hurry here. Okay, let's erase that. And actually, I'm going to kind of back up on this and start with the pi over 2 like this. Okay, so just kind of get this down a little bit better here. Okay, so we start with the 0. We multiply it by 2 and then add the phase shift in the factored form. So we take the 0 times the value of b, which is 2. and then we add the phase shift, which is pi over 2. So that gives pi over 2. So your first point's pi over 2. The second point is pi over 2. Okay, what we're going to do is we're going to divide that by 2. So we're multiplying by a half, and then add the phase shift like that. This right here should have been divided by 2. So that gives pi over 4 plus pi over 2. Now pi over 2 you can get a common denominator on and change it to that. So you get 3 pi over 4, like that. Okay, take the next one. Take pi, divide it by the value of b, which is this. Add the phase shift, which is pi over 2. That will give 2 pi over 2, so that's going to get pi like this. Now to me it's just as easy to count by the increment, but you can keep doing this. If you like doing it this way, do it this way. So we're going to do 3 pi over 2 divided by b. So if we divide by 2, that's the same as multiplying by half. Now add the phase shift. Okay, so that's going to be 3 pi over 4. I'm going to get a common denominator, changing that to 2 pi over 4. So that's going to give 5 pi over 4. Okay, and then we would do on this, the next one, the last one, you would do 2 pi. So you would end up doing 2 pi divided by b plus the phase shift. Okay, so that's going to give 3 pi over 2 like that. Okay, then what they're saying is just multiply the y coordinates by a and add d. Now we don't have a d value on this, so you just multiply these. So 0 times, and we have an amplitude of 3, so that's still 0. This becomes 3. This becomes 0, -3 and 0 like that. So you can follow that and everything. I never do the problems that way, but that's the way the textbook often explains how to do that. And if you look at the graph we just did on the previous page, like notice that you have 3 pi over 4 is 3. So if you looked at what we graphed on a previous page, you would see that, okay? Notice we have 3 pi, 3. All the points that we just found were basically the same. I just don't like to do it that way because I like to do things a little bit more in my head. So that'll take care of that then. Okay, I'm going to finish up this section with just a couple of more things. Just a little bit more repetition and one more example. Okay, so what we're going to do on this is identify everything in this problem. So the amplitude is 1/2. Okay, the period is 2 pi over 4, which reduces to pi over 2. Now this one isn't a factored form, so that's a factored form, so that phase shift is going to be pi to the right. And then this time we have a vertical translation of up 2. All right, now what we're going to do is do this in one step. I'm going to just show you how to do one step. And then we'll maybe do this problem the other way so that you can take your pick as to which way you like doing better. So take the period, which is pi over 2, divide by 4. Dividing by 4 is the same thing as multiplying by 1/4, so that's pi over 8. And that will tell you how to increment your x-axis, okay? So we're going to go down. Let me get a coordinate system built on this. And we'll show you how to do this all in one step. Okay, or at least maybe even 2 steps. It's kind of up to you. You can learn to do it all in one step though. So what we're going to do is we're going to count by pi over 8s, like this. Okay, so I'm going to put pi over 8 there, 2 pi over 8. Okay, now 2 pi over 8 reduces to pi over 4. Then we go to 3 pi over 8, 4 pi over 8, which is really pi over 2. And then we can go to 5 pi over 8 if we want to. Let's just keep going with this one because we do have a phase shift of pi to the right. So let's keep going until we hit pi. So we got 4 pi over 8, 5 pi over 8, 6 pi over 8. 6 pi over 8 is really 3 pi over 4. 7 pi over 8. 8 pi over 8 is pi. So that takes us all the way to the phase shift. Okay, there's other ways to do this, but I'm just going to go to wherever the phase shift is just to teach this problem. Okay, we have an amplitude of 1/2, and then we're switching up 2. So putting those two things together, it would make a lot of sense to probably go up to 3 and maybe down to -3, and then you'll have, you know, some halfway points in there too that we might need to consider. Okay, so what we're going to do is we're going to start by graphing just this one piece of the problem. So we're graphing y equals negative 1/2 cosine of 4 times x minus pi. This has every kind of transformation in it there is. So what we're going to do is just kind of start by looking at really everything except these two things. Those are the last two things that you ought to do, is the amplitude, reflection, and up-down stuff. So what we're going to focus on, and to me this is the way you always do these problems, is work with this part of the problem. Work with things that are affecting x. Okay, a phase shift affects x, a period change affects x. So that's where you should start, is just do that graph and don't worry about anything else. Now I can do this in my head. I don't need a unit circle or anything. Okay, a cosine starts high. So if we start at the phase shift, which is pi, then notice that your cosine starts here. It phase shifts all the way over to pi, so that's your first point. Okay, that's where a cosine wave starts. It moves over there. Okay, now if you went backwards through this cycle, then the cosine would hit there. That point's going to go all the way over here, and so forth. Like I said, once you get about 2 points, you can predict where the rest of them are. So this is going to go down to -1. It's going to go up there, up to 1, down to the x-intercept, down to -1, back there, and like that, and so forth. So that is the graph of what I call the x transformations. Right there. Again, we started at the phase shift. See, that cosine starts high, that's where it goes. And then we're working backwards through the cycle. Now just do this in your head. And once you get about 2 or 3 points, then you'll be in business. Okay, so we're going to do this. This y value right here has a y value of 1. So we're going to take -1/2 times 1 plus 2. Just do that in one step. That's -1/2 plus 2, that's 1.5. So that point right there is going to move up to 1.5. Okay, and that takes care of that point. Take the next one. That has a y value of 0. So take 0 times -1/2 plus 2. That gives 2. So that point translates to that point like that. Okay, take this one. This one has a y value of -1. So take -1 times -1/2 plus 2. So that's 1/2 plus 2. That is 2.5. So that point right there is going to become the maximum like that. Now see, I've gone through key points. This is like a midpoint, max. So this one's going to be ready to go there. This one's going to be ready to go to its minimum. Okay, and so forth. So that would take you right there. If you just keep going through this, this point right here is going to go back to the midpoint. This point right here is going to go to the max. This point right here is going to go match with these points here. And then this point right here is going to match with these points here, like that. So then if you just sort of carefully cycle through that, that would be the final product like that. I think I missed a point on that. It's really hard to draw that thing out. So that's how that would go. Now this problem can get fairly complicated, so I want to show you that if we picked a point, and why don't we just say like 0. Let's just check this point right here. So let's say x is equal to 0, and let's plug in x equals 0 into our function. So we have y equals -1/2 cosine 4 times 0 minus pi plus 2. Just work out the whole thing and see what happens. So that is -1/2 cosine. This whole thing is -4 pi plus 2. Okay, look at a unit circle. There's -2 pi, -4 pi would be 0. So you would have -1/2 times 0 plus 2 like that. Okay, so everything just kind of matches up. If you go through and sketch everything out, then you should be able to get a good... Hold on. Whoa. What am I looking for? Okay, sorry. What? I even highlighted the right thing and I wasn't paying attention here. Sorry. Okay. The x value is 1, so basically that should be 1 right there. Okay, the cosine of -4 pi is 1. I'm getting in a hurry here, sorry. Okay, so let's change that to a 1. Okay, now look what we have. We have -1/2 plus 2, so that's 1.5. And that's what that y value is. That has a y value of 1.5. Okay? So basically you just kind of cycle through these points. So notice that the maximums ended up all having the same value. This, and this all have the same translated value. And then the low point, since you had a reflection, ended up being the high point now, and so forth. So that's how your wave is going to go. Okay, so I think that will finish up. I do like to kind of finish this section up just by showing you how this would go with the other method, just in case you're interested, because sometimes students just do better with these problems with the method that the textbook shows. So I'm going to write down the function and then close off the lecture with this second method of doing this then. Okay, so what we're going to do here is, let me go ahead and let's write down the function that I'm graphing here. So we are working with y equals -1/2 cosine of 4 times x minus pi plus 2. Okay, so what they say is, just look at the key points on a sine. Okay, so if you had and this should say the 5 key points of a cosine wave. So let's just kind of start by looking at this. Okay, if you had a basic y equals cosine, okay, like this, y equals cosine, here's what you could do. You have 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, we learned that the values go like this: high, midpoint, low, midpoint, back to the high point like that. So what they're saying is, when you make your new chart, what you want to do is take, and first of all, transform your x values by doing this. Take that 0, divide by 4, then add the phase shift. That's what they're saying. Divide by b, add c. That's b, that's c. Okay, so that gives pi. So that's the new point. That's where it transforms to. Go to the next one. Do the same thing. Take pi over 2, divide it by b, add c. So that's going to be pi over 2 times a fourth plus pi. So that will be pi over 8 plus, and I'm going to change this to 8 pi over 8, like that. So you divide by 4, and then you add the next value like that. So that's going to be 8 pi over 8. That will be 9 pi over 8. Now, we didn't take the graph out this far, but if we did, we would have that point. That's one of the reasons I don't like to do the problems this way. I don't like to change the coordinates like that. It's a worthwhile thing to show students, though. Now we're going to take this one. We're going to take pi divided by 4, the b value, and then add the phase shift. So that's really going to be pi over 4 plus 4 pi over 4. So that's going to be 5 pi over 4. Okay, then we're going to do the next one here. Let's just do this down here. So let's take 3 pi over 2. Again, 3 pi over 2 gets divided by 4, then you add the 2. So that's going to be 3 pi over 2 times a fourth plus 2. So that's equal to 3 pi over 8 plus 2. Okay, so we'll do that. Hold on, I'm adding the wrong number on this now. Okay, so I'm okay. Let me just move this thing down here. Okay, not 2. You need to be adding the phase shift. So we do that. Okay, so I'm going to just write that when you add pi to it, that's 8 pi over 8. So that becomes 11 pi over 8. Okay, now you have a pattern on this, and you can keep going through that if you want to. Now we're going to do 2 pi divided by 4 and add the phase shift pi. So that's really pi over 2 plus, and then I'm going to change pi to 2 pi over 2. So that gives 3 pi over 2. Okay, now what you do with the y values is you go like this. Okay, what you're going to do with that is you multiply by a and add d. So you take 1 times -1/2 and you add that. Okay, if you work that out, you got 1.5, just like we did before. Okay, that takes care of that. Take the next y value, 0. Negative 1/2 times 0 plus 2 is going to give 2. Okay, take the next y value. Negative 1/2 times negative 1 plus 2 is going to be 1/2 plus 2, so that's 2.5. Okay, then do the next one, 0. Negative 1/2 times 0 plus 2 is going to give you back to 2. And then finally, the last one, negative 1/2 times 1 plus 2 is going to give 1.5. Now what happens on this is would be an extension of the graph. So what I want to kind of do on this then to finish this up is I'm going to take a little screenshot of this thing just to show you what would have happened on the other page if we did it this way. Okay, so let me move back up to where I was. And if we go down here and look at the graph we just drew, you can kind of see that if you worked through that cycle, then you would end up basically finding about the same thing anyway. It's just you would go out a little bit further in the cycle when you do that. So you kind of notice on this that if you went to pi, we had 1.5. Well, that's what we had. And then if you look at the cycle at 9 pi over 8, which would be this point here, you'd be ready to go back to the top, and you would just keep cycling through that. So you can certainly do the problem this way. So notice that this matches that point. And then if you went out one more, that would go there. Then if you went out another one, that would go to 2.5. And it's just an extension of the cycle is all that is then. Okay. All right, well, these problems take practice, no doubt about it. So work on these things, and you should be able to get these taken care of. All right, hope this helped.